In this video, I'll show you how to optimize Windows, clean up useless background processes, fix important graphics settings, and adjust your games for much higher FPS without buying new parts. Some PCs may get a small boost, some may get a huge boost, and in the right cases, you can actually double your FPS. Let's start with the settings that make the biggest difference first. Number 1. The real target. Doubling your FPS sounds like a simple promise, but what it really means is cutting away the biggest bottleneck in your system. Instead of hopping one random tweak will save everything. In most cases, low FPS comes from one of four problems. The game is rendering too much for the GPU, the CPU is getting overloaded, the system is wasting resources in the background, or the PC is not even using the right display or graphics setup in the first place. Official guidance from Microsoft, Epic, NVIDIA, AMD, and Intel all points to the same pattern. The biggest gains usually come from reducing render cost, using the right GPU, updating drivers, and setting power and graphics options correctly. Windows tweaks help, but they are usually the cleanup step, not the main event. Number 2. Start with proof. Before changing anything, create a restore point and write down your baseline. If you skip that step, you can end up with a broken setup and no clean way back. Microsoft explains how to turn on system protection and create a restore point, and that is worth doing before any serious performance work. After that, test one game in one repeatable spot. Use a built-in benchmark if the game has one. If not, pick a route, play it the same way every time and record the result. Steam has a built-in performance monitor, CS2 has an official telemetry HUD, and CapFrameX is a solid frametime tool. Do not look only at average FPS. Frametime consistency and 1% lows are what make the game feel smooth. Number 3. Fix the obvious mistakes. A shocking amount of bad performance comes from basic setup errors. First, check your monitor refresh rate in Windows. A lot of people buy a fast monitor and leave it at 60 Hz without realizing it. Microsoft shows the path under Settings, System, Display, Advanced Display, and Valve's own CS2 support says to use the monitor's highest refresh rate. Next, make sure the game is using the high-performance GPU if your system has both integrated graphics and a dedicated graphics card. Windows lets you set that per app under Graphics Settings. Then, update your graphics driver from NVIDIA, AMD, or Intel, or use your laptop maker's approved package if your model depends on custom drivers. These are boring fixes, but they often matter more than flashy so-called secret tweaks. Number 4. Use the right Windows gaming settings. Now go through the Windows settings that are actually meant for gaming. Turn on game mode. Turn on optimizations for windowed games if you play borderless or windowed titles. Set power mode to best performance if you are plugged in and battery life is not the priority. Microsoft documents all of these, and they are safe, reversible, and easy to test. If your system supports hardware-accelerated GPU scheduling, test it both on and off because results can vary by hardware and game. If you see Windows Automatic Super Resolution on supported hardware and supported games, that is also worth testing. The key idea here is simple. Use the settings that change how Windows schedules work for games, but test each one instead of assuming every toggle is always better. Number 5. Cut the background waste. Once the core gaming settings are on, reduce the stuff that steals resources. Open Task Manager and review startup apps. Disable anything you do not need launching when Windows starts. Microsoft also notes that unnecessary notifications can create interruptions and offer small performance improvements when turned off, and Windows visual effects can be reduced for better responsiveness on weaker systems. So if your PC is aging, turn off the cosmetic extras first, not because they are giant FPS boosters, but because they help the system stay focused on the game. Delivery optimization can also be set so Windows is not sharing update data with other devices over your connection. None of this usually doubles FPS by itself, but together it removes easy waste and makes the rest of your testing cleaner. Number 6. Be careful with security trade-offs. This is where a lot of optimization videos get reckless. You will often see people turn off memory integrity, also known as HVCI, because it can add some overhead on certain systems. Microsoft makes it clear that memory integrity is a security feature designed to protect core Windows processes from malicious low-level drivers, and Microsoft also documents that turning it off requires a restart. So here is the right way to handle it. Treat it as an optional test, not a default recommendation. If you test it and see no meaningful gain, turn it back on and keep the protection. If you do see a gain and you decide to leave it off, understand exactly what you are trading away. On a general audience guide, that choice should always be explained honestly. Number 7. Tune the GPU driver the smart way. Driver control panels can help, but only if you stay disciplined. On NVIDIA, official documentation covers low latency mode, texture filtering quality, V-Sync, G-Sync, and maximum frame rate. On AMD, official documentation covers texture filtering quality, surface format optimization, and tessellation controls, including the fact that lower tessellation can reduce overhead and that surface format optimization can improve performance. Intel's graphics software also offers low latency and game-focused controls on supported hardware. The smart approach is not to flip everything at once. Start with settings that reduce overhead without badly hurting image quality. If you use NVIDIA, low latency mode and a more performance-oriented texture filtering profile are reasonable tests. If you use AMD, surface format optimization and lower tessellation are worth checking. Test one change, then move on. Number 8. Separate FPS from latency. A lot of people mix up smoothness, frame rate, and input delay as if they are the same thing. They are related, but not identical. NVIDIA's own documentation explains that low latency mode works by limiting how many frames the CPU prepares ahead of the GPU. That can help responsiveness, but it is not the same thing as magically increasing raw FPS. In some games, a lower latency setup may even look a little different from a max throughput setup. So when you are tuning, ask yourself what you are chasing. If your main problem is input delay, latency settings matter. If your main problem is a low frame rate, render cost matters more. And if your frame rate is high but the game still feels bad, the real problem may be poor frame time consistency rather than the average number itself. Number 9. Learn the bottleneck fast. The fastest way to understand what is holding you back is to change resolution and watch what happens. If you lower internal resolution or switch on a strong upscaler and your FPS jumps hard, you were GPU limited. If you lower resolution and almost nothing changes, you are probably limited by the CPU, by memory speed, by heat, or by the engine itself. NVIDIA's DLSS documentation explicitly says that rendering fewer pixels helps in GPU-bound cases, and not every game gains the same way when the CPU is the limit. This one test saves a huge amount of time because it tells you where to focus next. Do not keep changing shadows and textures for an hour if the real issue is that your CPU is already tapped out or your laptop is thermal throttling. Number 10. Go after the heavy in-game settings first. Once you know the bottleneck, go after the settings that usually matter most. Resolution is the biggest one for most GPU-limited games. After that, shadows, anti-aliasing, reflections, global illumination, view distance, volumetric effects, and post-processing usually cost more than textures alone. In Rocket League, Epic's own support specifically recommends lowering anti-aliasing, render quality, render detail, texture detail, world detail, and particle detail for smoother play. Fortnite goes even further by offering a dedicated performance mode built for weaker hardware. The big lesson is that game settings are not equal. Lowering one expensive option can matter more than lowering 5 cheap ones. That is why blind preset changes are less effective than targeting the true performance killers. Number 11. Use built-in performance modes when they exist. If a game has a real performance mode, use it before you start chasing complicated Windows tricks. Fortnite is the clearest example because Epic explains exactly what performance mode does and even gives hardware examples where the gains are dramatic on older systems. Epic also says you can remove high-resolution textures to save over 14 gigabytes of storage when performance mode is enabled. That matters because storage pressure and asset streaming can contribute to stutter on weaker machines. So if your game offers a mode that is specifically designed for lower-end hardware, start there. It is usually more stable than random community tweaks, and it is supported by the developer instead of being a guess from a forum post. Number 12. Use upscaling the right way. If your game supports DLSS, FSR, or ZSS, those can be some of the easiest ways to gain FPS without making the image fall apart. AMD describes FSR as a way to boost frame rates in supported games. NVIDIA explains that DLSS Super Resolution boosts performance by rendering fewer pixels in GPU-bound cases, and Intel describes ZSS as a performance-boosting upscaling technology. The practical rule is simple. If your GPU is the limit, upscaling can be a very real win. Start with quality mode, then move to balanced, then performance only if you still need more headroom. Frame generation is a separate tool. It can increase displayed frame rate and smoothness in supported games, but it is not always the best first answer for competitive games where latency matters more. Number 13. Understand when Windows tweaks will disappoint. A lot of viewers expect Windows cleanup alone to double performance, and that usually does not happen on a system that was already mostly healthy. Microsoft's gaming and performance guidance focuses on correct graphics settings, power mode, startup activity, notifications, visual effects, and app GPU assignment. Epic's own troubleshooting pages also prioritize drivers, the correct GPU, power mode, background programs, and lower graphics settings. So if you already have a modern system, current drivers, a clean startup, and the right GPU selected, you should not expect a massive FPS jump from turning off a few Windows extras. In other words, if your PC is decent and already configured correctly, the real gains usually come from the game itself, especially resolution and graphics load. That is the expectation viewers need to hear clearly. Number 14. Use memory correctly. RAM settings matter more than a lot of people realize, especially in CPU-heavy games. Intel XMP and AMD Expo exist so your memory can run at its rated performance profile instead of a slower default. Both companies describe these as easy-to-activate memory overclocking profiles for compatible systems. That does not mean you should blindly overclock everything, but it does mean you should check whether your memory is actually running at the speed you paid for. Enter BIOS. Find XMP if you are on Intel or Expo if you are on AMD. Enable the correct profile, save, boot back into Windows, and test stability. If the system becomes unstable, turn it back off or use a lower profile. Stable performance is always better than a slightly higher number with random crashes. Number 15. Watch temperatures and power behavior. If your FPS starts okay and then drops after playing for a while, heat may be the real issue. Epic's own Fortnite support says overheating can damage performance after long sessions and recommends keeping fans and vents clean. This is especially important for laptops and compact desktops. Also pay attention to whether you are plugged in. Windows Power Mode exists for a reason, and battery-saving behavior absolutely slows games down. If you are on a laptop, gaming unplugged is one of the fastest ways to lose a big chunk of performance. So before you call your PC weak, make sure it is cool, clean, and running in a performance-focused power mode while connected to power. Otherwise, you may be benchmarking the battery policy, not the hardware. Number 16. Use game-specific solutions when they are mature. Some games have performance ecosystems that are far better than generic Windows tweaks. Team Fortress 2 is a perfect example. Master Config openly says it targets heavily unoptimized features, is documented in detail, and can make the game smoother, reduce load times, and increase FPS. Minecraft Java has a similar case with Sodium, which describes itself as a rendering engine replacement that improves frame rates and reduces microstutter. These tools can be excellent, but the rule is simple. Use trusted, maintained, well-documented projects. Back up your existing settings first. For TF2, Master Config even documents installation and cleanup. If you are using game-specific configs, do not treat them like Windows-level magic. Treat them like targeted tools for specific games. Number 17. Example thinking with real games. Here is the pattern across popular games. In Counter-Strike 2, Valve itself says to use your highest refresh rate and supports an official telemetry HUD, which tells you that measuring smoothness and display setup matters. In Rocket League, developer support points directly to lower video settings, the correct GPU, current drivers, and Windows Power Mode. In Fortnite, Epic offers a true performance mode with documented before and after examples on weaker machines. In Minecraft Bedrock, Mojang support documents lowering video settings to improve performance, and in Java, mature projects like Sodium exist because the community has identified rendering as a major target. Put all of that together, and one truth stands out. The best FPS guides are not random. They follow the path the game and hardware makers already point toward. Number 18. Avoid fake optimization culture. This is where you save viewers from bad advice. Be careful with all-in-one debloat scripts, mystery registry files, ancient launch options, and dramatic claims like, "This one setting gives 300 more FPS in every game." Microsoft's own support material focuses on safe controls like startup apps, notifications, visual effects, power mode, graphics preferences, and restore points. Even TF2-focused docs warn against silly launch options that go too far or are not useful for reasonable users. The real problem with fake optimization culture is not just that some tweaks do nothing. It is that they make troubleshooting harder. If your game starts crashing or looking broken, you want to know exactly which change caused it. Safe, incremental tuning always beats chaos. Number 19. Build your testing order. The cleanest order is this. First, baseline the game. Second, check refresh rate, drivers, and which GPU the game is using. Third, turn on Windows Game Mode, use Best Performance Power Mode, and clean up startup apps and notifications. Fourth, test in-game resolution and the heavy graphics options. Fifth, test upscaling or a built-in performance mode if the game supports it. Sixth, test optional driver panel settings. Seventh, test deeper options like memory integrity only if you understand the trade-off. Eighth, if the game has a trusted community performance project, test that with a backup. This order matters because it gets you to the biggest wins first and keeps your changes easy to track. If you still cannot get acceptable performance after that, the system may simply be at its hardware limit. Number 20. Know when you actually succeeded. You did not really fix the problem just because one screenshot shows a higher FPS number. A real success looks like this. The game feels smoother, the 1% lows improved, stutter is reduced, input feels more consistent, and the image quality trade-off still makes sense for the way you play. If you are competitive, you may accept lower visuals for cleaner motion and lower latency. If you are playing a single-player game, you may keep more image quality and use upscaling to hold a stable frame rate. The important part is that your result is deliberate. You measured before and after. You know which change helped. You know which one did nothing. And if something breaks later, you know exactly how to undo it instead of guessing.